So this is the assignment we have. It's basically an IP 300 beam, to which two horizontal bracings are connecting. The horizontal bracings are CHS 139.7 by 3.6. And the approach angles are 45 degrees, and it's a symmetric connection. So whatever is valid for the left-hand side is valid for the right-hand side as well. If you come down to the notes, the horizontal brace is lowered by 100 millimeters from the top of steel. You can see it from this view. This is the top of steel, and it's the top of the pipe is 100 millimeters below the top of the steel. And the two horizontal braces are approaching at an angle of 45 degrees. The two horizontal braces are cut by the welded plate as shown. So there's the plate is going through this welded plate is going through the pipes, and there are two plates, one on top, one on they're called the loose plates. They will basically be shipped separately, and there's one on the top and one on the bottom, and you can basically zoom in to see what the exact shape of the connection is. There's a gusset plate, there's the loose plate at the top, the loose plate at the bottom, then there's this welded plate which is coming out of the pipe. It's partly welded to the pipe. It goes inside the pipe, it cuts the pipe, and it's welded over here. And then there are two cap plates, one at the top and one at the bottom. Those are thin, they're not really structurally functional, just there to close the opening. And you've got 6 bolts on this side and 6 bolts on that side. That's the connection which we will attempt using the variables, using the dimensional information for the left-hand side, and then we'll basically do the same for the right-hand side. So let's start. So we can begin by zooming in over here and noting that this is the working point where the two braces are meeting, and the brace has been pulled back. So if you see this dimension 469.15, it's been pulled back from the working point by that amount, 469.15 millimeters. So let's start from there. So here I've just entered the model as shown. The braces are 100 millimeters pulled down from the top of the steel, but I'm going to pull back that amount. Let's just go back and check it. It's 469.15. So I'll start by putting my work plane to this object, to this left object, so that my X is aligned with that. And then I'm going to select the object, select this blob, and make it move minus 460, whatever the number was. Let's check it again. 469.15. So 469.15 minus in the minus X direction, and that's the amount of pullback I need. I've just entered this right brace as well, but we probably won't be needing it. Once we've created the stuff on the left-hand side, we'll just mirror the whole thing to the right-hand side as well. Now let's get back to the drawing and see that these loose plates on top and the bottom, they have, let's see the dimensions. Their dimensions are 350 by 140, and they are placed 16 millimeters ahead of where the brace has been cut off. So after the brace, there are these cap plates of 6 millimeters and a further 10, so a total of 16. But the size of the plate is 350 by 140. So we go back to the model. Let me just put back the work plane to this object over here. And we want to create a 350 by 140 plate over here. So we go to our steel menu, go to the contour plate, hover over this point, press enter, and we say at our 350 by 140. That was the rectangular plate, and since the work plane is in that direction, it's going to create a plate for us in that direction with the dimensions of 350 by 140. At the moment, I'm not worried about where it is. It's always a good idea to just create the thing first and then you can move it. So just select that, and now we can say move special in such a way that this point, once you have this X direction set, then you can play around a bit. You can select this point, goes to this point, but you hover over that and you say DX16, because it's 16 millimeters further away from that, like that, and you will see a number over here in the X direction, 191. Just remove the Y coordinate and just say move, and now you will see that the plate has been created with that size over there. Now, just going back to the drawing, we see that when we get this plate is, it says approximately 20 millimeters from the inner face of the web. So let me just check that so that to make sure I'm at the right place. I can zoom in, right click and say measure distance from here to here, and the distance is 19.89, so it's approximately 20, so I'm probably in the right place. We can see that the loose plate which we just created, there's two of those by the way, we just created one, we can copy that later, but the thickness is given as 12 millimeters, so we go back to the model, double click on the plate and make the thickness 12 millimeters like that, go back to the drawing, and now let's focus on the welded plate, which is the one which is going through the brace, like that. It has a size of 346 by 165. So let's just 346 by 165. Let's just create it first. Once again, we can hover over this point and say at R 346 by 165, like that. So we more or less get it in almost the right position, but it's not in the right position. For it to be in the right position, it would need to be 160 millimeters. Let's just zoom in like that. 160 millimeters behind the amount of extrusion, the amount it cuts into the brace is 160, which is probably also given over here as 160. So it needs to be, that point needs to be 160 behind. So what do we do about that? Let's see. Go back to the model. Once again, we can select this one and say move, like that, linear, in such a way that this point goes to this point. Press enter and say dx minus 160, was it? Yeah, let's do that, and it'll give us the x offset of about 13 millimeters. Let's remove the y offset because we chose random points. This one is 12.99. Whenever you see something like this, always a good idea to make it 13 and make it like that. And now we can see that if I measure the distance from here to here, it'll be 160 in the x direction, which, let me just confirm, is what we want, 160. So this one is now, the total length is 346. We've got 146 jutting out, but the 160 inside the brace. We note that the thickness of the plate is 10 millimeters, this welded plate, and this welded plate should obviously be at the same level as the gusset plate, and therefore it should also be in the middle of the pipe. So it's 10 millimeters and it's in the middle of the pipe. Let's go back to the model. This is the plate we had. We convert that into 10 millimeters, like that. So that is done. Let's go around and see if we can see that their locations are not correct. They need to be moved. So we need to bring this plate to the middle of the pipe. So when we're dealing with pipes, sometimes it's you want to snap to the middle and there's nothing in the middle to snap to. So, and you've already pulled it back as well. So what you can do is you can select the pipe, for example, and maybe create some gravity lines for that, because those will be at the center, and this will create a line going through the center. And since we want this plate to be, the middle of this plate to be at the level of the line, what we can do is we can select that plate and say move linear, and then select the midpoint of that plate, and then just select any point on this line by pressing the control key, like that. And this will give us a Z offset, and the other offsets are meaningless, so we need to convert them to 0. The Z1 is the one which we want, and if we say move, it'll basically bring the plate to the required elevation, and that's what we want. This one would need to then We also we can just say move linear in such a way that the bottom of this is the same as the top of that, like that. That'll give another Z offset. Once again, we can zero the X and Y offsets like that, and that's going to put the plate where it needs to be. You can double click on that, maybe change the color so that it's easier to see. And we see that with a few clicks, we've managed to bring the plates where they need to be. Since we want two of these yellow plates, once again, we can say copy linear in such a way that the top is the same as the bottom of this. And once again, we remove the X and Y offsets and we say copy. And we have the two plates ready for whatever we want to do with it. Now that we have those three plates modeled, let's focus on the gusset plate itself. And for that, we note that the gusset plate is 10 millimeters away from this welded plate in this direction, but it's also jutting out from the loose plates 10 millimeters to the left and right. So that will make things easy for us. 10 millimeters in that direction, but then jutting out 10 like that as well. So we go back to the model, and what we can do is, for example, we can go to the parallel points command, press on the shift key, and just put a number 10 inside, and then use these 2 points to create 2 parallel points which are 10 millimeters away. Now it might look that these are also 10 millimeters away from that, but they're not. So what we need is we need extension points. Click on the shift key once again with a -10 setting, and this time what we can do is we can click on this and go perpendicular, and that'll give a point which is -10 millimeters away in that direction, and that's actually this point. This is the one we want, not the one we created first. And similarly on the other side, if you go like that, we'll create a point which is 10 millimeters, and we can actually measure that from here to here. It's 10 millimeters. That's what we want. So we can delete the ones which we created earlier because we don't need them. And then the gusset plate would go straight from here until it hits the web. So we can use the projected point for that. Press the control key to select any point on the line, this inner web line, and then just select this point. So you get that point over there. Once you have these 3 points, just select them because the other side of the gusset plate is just symmetric, and you can put your work plane over here like that. Right click and say copy mirror from this point to, you can put your mirror plane like that, And once you've done that, if you click on the run button over there, you will get the mirror image of those points on the other side as well. And once you do that, you can go to the seal menu, go to your contour plate command, and basically just start clicking on these points like that. And that will basically be your gusset plate. Now, we know that the level of the gusset plate will not be the same as where it should be. It's probably going to be at the top. First of all, we need the thickness of the gusset plate. So let's see what the thickness of the gusset plate is given as 10 millimeters over here. And of course, it's in the middle. It's at the same level as the welded plate coming out of the brace. So let's first of all change the thickness to 10 millimeters. Like that. Maybe we can even change the color to make it look different from the others. And once we have that, then we can basically just move it like that, such that the middle of this is, I think I didn't select it. Yeah, that point needs to go to the middle of this, like that. And we only need the Z component, so we delete the others. We say move, and we have the gusset plate where we want it to be. Now that we have the gusset plate as well, we can quickly enter these bolts. So for that, we just take a look at the loose plates because they'll give us the dimensions. So we zoom in and we see that the bolt is 35 millimeters ahead from the edge of the loose plate,
and then 2 more with a distance of 50 each, and the distance in the other direction is 90. So 35, 50 each, and 90. Just keep that in mind. And they're M16 bolts because the holes are given as 18 millimeters. 35, 50, 50, 90 in the other direction. Let's go back to the model. Let's go to the bolt command. Let's go to the bolt with auto coordinate system. Select the yellow loose plate, select the welded plate, the other yellow loose plate, like that. Right click, and you can start off by selecting the midpoint over there to the midpoint on the other side, like that. Now it might give you a little error because it's on the edge, but all we need to do is select this. First of all, let's once again put the work plane on the brace, like that, like that. So once we have that, we have the work plane in that direction. This is the X direction. What we can do now is we can select those poles and move them 35, if you remember, in the X direction. Let's just reset that, say 35, and we will get the basic bolts. Now we can go in and do the other modifications, like make it an M16 bolt, give it a tolerance of 2 millimeters, like that. Go to the positions tab. So the other direction, let me quickly go back and check. It was 50, 50, and 90. So this should be 2 into 50. This one should be 0 and 90. And we can make the middle for the Y alignment like that, and that will basically give us the bolts where we want them to be. Now the same can be done for the other side as well. This time the plates will be different. So we go back to the bolt command, like that. We select this one, we select the gusset plate, we select the bottom one, right click, we start off with this one, and we know that is the X direction, so we can actually just hover over that and say dx minus any number, like that. Once again, we get the same error because it's right on the edge and it can't find the position of the bolts. So we right click that, linear, this time in the minus Y direction. If we say 35, we can bring it there. And then we can double click on the bolt, make it M16 tolerance. It will, I can't match the bolts. I can match it only for the diameter, but not for the positions, because that's not usually what's required. So that part will need to be done manually, and this would need to be 0 into 90. This one would need to be middle again, basically like that. So you see very quickly we've managed to create the bolts as well. Now, if you remember, there are some side stiffeners on the left and right of the gusset plate. This is what they look like, the side stiffeners. And we can, I mean, I'm sure by now you can quickly make these. All the dimensions are given. You just need the points, maybe insert a few points and all that. So that's not really going to add to the repertoire. So what I would rather do is show you a little trick over here for that kind of a stiffener, in which the stiffener is basically running around. It's like that, and it's welded to a gusset plate as well. So it's not a normal stiffener like that. It's got extra points over there. If you go back to the model, under the detailing menu, there is a little macro called the extended stiffener macro. And if you can see the pink one over there, it's basically, it puts a stiffener around another plate. So if you click on that, what it asks for is the profile first. So you select the main beam, and then it asks for the gusset around which it will be placed. Then it asks for this point, the outer point of the gusset, this one over here, not this one, but this one over here. And if you click on that, it then asks for another gusset plate. Sometimes there are two gusset plates if there's a twin member or something. But since that's not the case in our case, we just right click at that point and right click again, and we see that a stiffener, which is almost identical to, it perhaps is identical, has been created like that. Maybe we just need to change the thickness of that. And we can do the same on the other side as well. Select this, select the gusset plate, select this point, and then just right click. And you have your two stiffeners ready to go. If you wanted to change their thicknesses, you could go inside the macros and change the thicknesses from here. We won't be doing that. Now we can actually cut this profile. If you remember from the drawing, this brace was cut by the welded plate. The welded plate was going through it basically. So we can just go to the edit command or the edit menu over there, go to the cut menu, and there we have this part cut option. And what we can do is we can click on that, and then we can select the brace, and then we need to select the part which is going to cut it, which is the welded plate over here, and basically that's it. And we right click, and if you just select this one and say show only, for example, you will see that the cut has been made now. That will also give us the points which we need perhaps to create the cap plates now. So let's just say show all, and now we're looking at the whole thing once again. Now I think the only thing which we have left are these cap plates, which are at the ends of the pipe. There are two of them on each brace, one at the top and one at the bottom. One goes above the welded plate, one goes below that. And the cap plate size has been given as 165 by 77.5. So just keep that in mind, 165 by 77.5. Like okay, let me just start doing it. So go back to the model. And what we can do is we can start with the contour plate. And since we have this point now, we can start from there to there. And then the height was 77.5. So we can say DZ 77.5 from there. Like that goes up, and then we come hover over this one, say DZ 77.5 again, and then we just close the loop, so we get a plate. Of course, it's not so thick, it needs to be much thinner, it needs to be 6 millimeters, and we can also change the color to maybe green, like that, and then we can select it and press Ctrl W to bring it to the outside. That's kind of where it needs to be. Of course, the dimensions are not correct because I just used those points. This 77.5 is correct, but this width should be 165. Let's go check that again. It should be 165. So we go back in there and we click on this one and we say 165. Press the middle button because it needs to go on both sides, like that, and then click on this one and make that 165 again as well. And once we have that, we can select these 2 points like this and give it a chamfer of 77.5. Now, sometimes, so when I try 77.5, sometimes you can get a numerical error, so it only does one side because the two sides are coming at exactly the same point, and there could be numerical issues at that point. So you the way around that is pretty simple. Just make it 499, and it's going to turn out fine in the drawings as well. But if you just do that, then you will get the circles on both sides. Now, once you have that cap plate over there, you want to mirror it to the other side. But the mirroring plane right now needs to be perpendicular. You need to put the work plane in this plane of the cap plate. So what you could do is you could just put, say, set work plane to surface, and you could use maybe this surface over here, or you could use the surface of the cap plate itself. But basically you have a surface like that, and then you could select the cap plate, say copy mirror, and you could select the midpoint of that plate. And let's see what that's the Y direction. So you can select any point on the Y direction. Say DY 100, doesn't matter. So you have your mirroring plane, and now you've selected the plate already. If you say run, it's going to go to the other side, like that. So that basically does the finishes the connection. If you notice, and all that is required now is to mirror all that we've done to the other side. Now, as far as the mirroring of everything we've created on this side is concerned, we could do it in two different ways. One way would be to actually delete this profile, which we already have over there, and just select everything on this side and mirror it to the other side. That would be one way of doing it. but sometimes you don't, you want to keep this profile because maybe you've made a connection on the other side or something which is different. So let's just do that. Let's do the scenario in which you want to keep this profile. Well, in that case, you would first of all just match. You want to pull this back on the you want to give it the same offset as we gave it, 469.15. I'm just going to select this and say match elements to this one so that it's pulled back in the same way. And then I'm just going to select everything over here and this bolt. And I'm going to deselect this profile because this one already exists on the other side. And then I'm just going to check what I've selected. I'm going to press enter. And it says you've selected 5 plates. So just count those. We've got 3 plates, the welded plate, the 2 loose plates, and the 2 cap plates. So that looks fine. We've got 1 cut. So yeah, that's the cut which we use to cut the brace. And there's 2 bolt groups. So we seem to have done the selection correctly. We've got 1 cut, 5 plates, 2 bolt groups. That's what, there are some points in there as well that we don't really care about them. So once we've gotten the selection right, we can right click and say copy mirror along this middle line. So we select this one, and then we, since the work plane is over there, we just give it any point in the Y direction. So dy 100 could be any point. So that's the mirroring plane. And then we just say run. And when we do that, everything is copied to the other side, and we just need to confirm whether the cut has also arrived as well, because the cut would need to find, so we can just select this one and say show only, and you see that the new cut is available over here as well. So the bolts have come, the plates are here, the cuts are here, and we've managed to finish this connection in about 20 minutes or something, 20-30 minutes or something. Obviously, when we do it without talking, we can do it in a much shorter time.